and a little contributor of the nginx web server. I will show you a bunch of techniques, use cases, tricks for going massive. What I mean for going massive? I mean deploying multiple application, uWSGI application in our case, to one or multiple servers. When you need to build such architecture, you need to start with a bunch of steps. The first one is identifying your context. Do you trust or you don't trust the application that will run on your servers? Based on that choice, your path will change on how you will build the infrastructure of your massive deployments. Second step is measuring system resources. You need to account how much memory your servers have, how much CPU, how much disk space, the network bandwidth, and even if this is still a research topic, how much storage, seeing it as a kernel programmer point of view, how much storage, IO bandwidth you have. Last step, humans. How many sysadmins do you have? This is not too much important for, or better, this is not much related on how many applications can you deploy based on how much humans you have in your structure, but is related to how much docs, or how much skill you have to distribute to your sysadmins. Your objective is all of your sysadmins must have the same skill and must know the infrastructure of your massive architecture. This is not generic rules. These are my rules when I build infrastructure of that kind. The first rule is try to never reload system services when I update configuration. For updating configuration, I intend even when you have a new customer and you have to add a configuration for him. The second rule is try to let the user do the hard work. I don't want to configure their applications. I want they make their config file, especially for a project like uWSGI where you have hundreds of options and I don't want to mess with them one for each customer. Last point, I want to give users much freedom as possible as they will be more happy to pay me. nginx and uWSGI. nginx is a very scalable, fast, and cheap HTTP and speedy from the next release web server, but in such specific infrastructure we will use it as a proxy. uWSGI is an application server with the wrongest name ever, because it is not a uWSGI server as the vast majority of people think, but is an infrastructure, is a stack composed of various plugins for building massive infrastructure, and uWSGI is one of its plugins. You can use it for host Ruby apps, Perl apps, PHP, CGI, whatever it supports. We will start with a very simple architecture. We have a single server with nginx directly speaking with our client request and passing request to our backend application server, uWSGI. First step, configure nginx. This is for all of you more near to Apache style. This is a virtual host for nginx. You define the port on which to bind nginx, its server name, and a generic location. The relevant part are the one in red, where you set the server name. We are configuring example.com. And the second red line, where we set the Unix socket on which all the application requests will be passed. And this is a uWSGI configuration for a uWSGI app. The first three lines are a .ini file. I suggest you to start with very simple uWSGI configuration when you start learning it, because it can become very complex when you start studying it. So start with very simple config. And the last line is how you start it. So you start nginx, you start uWSGI, and your app will start working, I hope. Then we need to add a second app on a second domain. We will start adding another virtual host with different server name, with different Unix socket. But we have broken the first rule. If you will have 20 customers, you will need to write 20 server stanzas. It's impossible to manage. So we have broken the first rule. So we will update nginx to make it more smart. We will use only one virtual host. We will set a variable host name. This will be set to the host name of the machine. And the last one is the more important. Every time nginx will receive a request, it will map the name of the uWSGI socket with the host header of the request. So if you have a request for example.com, your socket will be mapped to /temp/example.com.socket for example2, the same rule apply. Then we have the first uWSGI problem. We have to start multiple instances, one for example.1, one for example2, so on. What's the proposed solution in the uWSGI project is the uWSGI Emperor. This is a kind of supervisor. It will start monitoring the directory you have specified as argument, and as soon as it is find a valid uWSGI config, it will start a new uWSGI instance, parsing that config file. Whenever you touch or modify that file, the app will be reloaded, and whenever you remove that file, the app will be destroyed. You can use the first syntax with a simple directory, or you can use a glob style to make some more complex rule. Remember to put quotes, or your shell will expand that path. uWSGI apps managed by an Emperor are called Vassal. The Emperor normally run as root, so you have to set the user and group ID of your customer. So as you see, we set UID, group ID, and the socket to the domain in such a case of your app. What if we need our app to answer to multiple domains? We simply add more socket options. That specific app for that specific customer will respond to 3 different domains. This part is end. Now we need to secure that app. This setup is good if you know the apps running on your server. Maybe it's good if you have developed that apps, but it's not good if you do not know what will run on your machine. Don't be afraid, it's only a series of shell commands. What are Linux control groups, C groups? More recent Linux kernels support that special file system in which you can create containers. So I decide that group of processes go in that container and will be limited in memory, CPU, whatever you want. To use it, you simply mount the C group file system in a directory of your choice. And to create a container, you simply create a directory in that file system. That directory will automatically contain all the supported limit included in the kernel. In that example, we will limit the CPU and memory. CPU share work in that way. If you set a container to 1024 and another one to 512, the first container will get twice the CPU of the other one. Here we limit to 200 megs of memory, and then here you substitute XYZ with the PID of your process. You put that process in that container. You don't need to make all of these commands, but you can simply set in your Vassal config in which C group you want your app to be run. uWSGI config parser includes a lot of tricks. The one I suggest you to use is that one. Use variables, placeholder in the uWSGI jargon. You set a custom variable, customer, map it to your customer user ID, and then you reuse it internally in that file. But do not abuse that config style. It offers a lot of semi-language syntactic style, but it's pretty unreadable. Looks like Perl. Templating is a better way to accomplish dry. We have two files. We have the one that's a real basal, and it includes a template we have defined. Now, we want to go further. We want to put nginx on another machine, and we want multiple uWSGI server for scaling. One app can have 12 uWSGI server responding to its request. Another customer that don't want to pay you too much will have another one instance, and so on. This is the new architecture. We have nginx on one server and two or more server running uWSGI. We changed the nginx config, but we have a problem. How the hell we can manage the IP addresses of our instances? We need to find a way to map a single domains to its specific uWSGI addresses, and one domain can map to multiple uWSGI addresses to make load balancing. The uWSGI project, there is a plugin called the Fastrouter that is simple a proxy for a uWSGI request. You can use it for failover, automatic load balancing, and it supports various mapping ways. For mapping ways, I mean domain, uWSGI address mapping. You run the Fastrouter in that way, and the second argument, Fastrouter subscription server, is the way we have chosen to support mappings. We will see that later. This is our new arch. We have a server in which nginx and Fastrouter run, and we have the two or more uWSGI server. This is our new nginx config. We simply pass all of the requests to the Fastrouter, and now we have our instances subscribing to it. You don't need to configure nginx anymore. Your app subscribes to it, and will start receiving requests. How subscribing works? It is a simple UDP datagram representing, containing the information about the instance. The minimal packet the subscription server receives is that one. It receives a key, the domain name, the address of the instance, and it's wait for making a weighted round robin. And this is our new basal config. We subscribe to two different domain names on the same subscription server. And the most funny part is the one in red, where you don't need to choose a port. The uWSGI will choose the first available port and will communicate it during the subscription. That syntax using the asterisk will allow you to reuse that file on all of your machine, as it will automatically find the first IP address corresponding to that globe. Another magic is that %n that will be mapped to the name of the basal file without the extension. So if you call that file customer1.ini, you can reuse that file for another series of your customer. We are now out of trusted mode. Why? We want our user to write their own uWSGI config, because they need to do the hard work. There is a teeny solution that's Emperor Tyrant mode. It's pretty useless in such a context. Practically, it try to get the user ID and group ID of the basal file and automatically set to it that basal to that specific user ID. But the most important thing is that now user can bind to whatever address they want. But we want to go further. We want to give a full Emperor to our customer. So we will have a big Emperor running as root and a series of Emperor running under the user ID of our customer, monitoring a specific directory in where our customer will put its config file, its bus. All of the buses the user will put under that directory automatically will be put in the container of that Emperor. The biggest problem is subscriptions are insecure by default. Writing a custom forged packet is very easy. I can even give you a Perl script for doing it in the test suite of uWSGI. So we will break the third rule. We have to find a way to secure that system. My solution, my currently preferred solution, is using RSA to sign your subscription packet. You only need to start the Fastrouter, passing it a directory containing all of the public keys of your customer, one for domain. Let's see how it works. Your customer will create its private key. Then it will create its public key. Then it will send you the public key, and you will copy in the directory you have used for the Fastrouter DB, renaming that public key to the name of the domain. And this is our final Fastrouter setup. We have a couple of new options here. The first one is master. Whenever you work with the uWSGI, you should enable the master. It will constantly monitor all of the components of your stack. It will reload it if they crash, and so on. Another part is, in that time, we have used a multicast address for subscription server. Sadly, multicast networking is not supported on the vast majority of clouding systems, so you will not be able to use it on Amazon EC2, for example. But I will say you later why this is important to use multicast if you can. And the other component is Fastrouter stats. It will bind to the socket you specify, and whenever you connect, you can use Telnet to that port, you will receive a JSON representation of the status of your Fastrouter, so all the subscribed instances, how much requests they have managed, and so on. Last part for enabling secure subscription system is that one. You specify the digest algorithm you want to use and the directory in which to look up for domains. And this is our final bus. It's look big, but there are more comments. I have defined a couple of variables in the beginning. The syntax for using the security system is the same on the server side. You choose a digest algorithm. It must be the same of the server one, otherwise it will never work. And you specify the path of your private key. Here, you are facing a limit of the uWSGI syntax parser. It is positional based. So you have to specify the uWSGI modifier. uWSGI modifier is a number the uWSGI server uses to know to which plugin to route a request. For example, the 01 means put the request in the Python plugin. The fifth one is per plugin, and so on. In that way, you are specifying subscribe to example.com as a 0 modifier, so a Python app, using that secure key. Again, we bind to a random port on the first available address. Is it over? More or less. I tend to like focusing on details, as the customer tend to like attention to details a lot. I suggest you to follow that path too. That's some trick. Push users to abuse idle and ship modes of uWSGI. You can use them to set a timeout of inactivity for your apps. As soon as it reaches, the app will be stopped. And as soon as it will receive another request, it will start again. The second trick is a bit controversial because I don't like it. The Emperor can receive events via RabbitMQ, for example, to tell it, please reload the tab, reconfigure the tab, and so on. As a sysadmin, I prefer to work directly on a file system-based approach. I find it more versatile. KSM is a Linux-specific feature. Practically, it's a kernel daemon scanning all of your memory, and as soon as it finds two equal pages of memory, it will merge them. It can be a memory saver or can be completely useless in a Python context, because reference counting of Python can simply make your shared object, I mean two apps with a similar object, completely different, because every one you make a request, the reference counting could increase. I suggest you to always monitor things. You can monitor the Fastrouter stats with Fastrouter stats. You can monitor the Emperor. It will say you how much vassal are starting, what's their status, and so on. Again, use multicast subscription address. Later I will say you why. If you do not like the secured subscription system, try to work with firewall. It's pretty hard, but maybe will avoid you to mess with the RSA keys that I know someone is scared of. Give a look at unshare namespace uWSGI options that abuse a bunch of new Linux kernel features for isolating apps. You will be able, using --unshare PID, to hide your processes from other users in the system, and so on. Why multicast? Because if you run dozens of nginx plus Fastrouter server, and they all bind to the same multicast address, you don't need to reconfigure your vassals. They will start broadcasting to all of the subscribed to multicast group nodes. So you can add all the nginx Fastrouter nodes you want without need to tell to the customer. What is missing? I haven't talked about static file serving. The current fashioned way is putting static files on the cloud or generally on other server and going with a multi-tenant architecture. Cloud services like the Active State Staccato pushes on using the uWSGI static file filters. I will not show you there because we will never finish. Long-running tasks like Celery, external daemons like memcached, you can use uWSGI to manage them, as it includes a touch daemon option for monitoring external daemons, but it's not so smart. So I suggest you to go to a solution like Supervisor or something similar. Database configuration is missing because it's not my job. I don't like that job. And please, whenever you write infrastructure for developers, give SSH to users. It's important. Do not treat users like monkey. Please, give them SSH. What I'm working on for the uWSGI project. A lot of users told me RSA are the most evil thing in the world. But thanks to GitHub, all of us know how to create SSH keys. So I will try to add support for SSH keys for the secure subscription system. There is still space for optimization in the subscription system. Its key-value store can be optimized still a lot, especially in the weighted round-robin algorithm. Currently, it's big O(n), so it's not good. But I think in a couple of days we'll release a patch for it. There is a lot of demand for alternatives to the RabbitMQ external manager for the Emperor, using a system like ZeroMQ or Redis. Again, I'm not still sure this is the best approach you can follow, but if a customer pay me for that, I will make it, no problem. And we are investigating persistent connection between the Fastrouter and uWSGI instances. This could be a security problem, and maybe the gaining will not be too much. Probably we will try using 0MQ as a communication layer between the Fastrouter and uWSGI instances. Does the Fastrouter introduce overhead? Yes, a bit, but we are talking about microseconds. It's practically irrelevant. Another question, is nginx really needed? What I've not told to you is that Fastrouter has various versions. That one is the uWSGI speaking one, but you have a Fastrouter speaking HTTP, so you can put it directly on the internet and let it manage a request. But I will be a foolish pushing it so early on such a product. You still need nginx, and nginx will be ever more versatile than every Fastrouter I can develop. Can I build the next PaaS ISP hosting platform with that? Yes, this is the purpose of the whole uWSGI project. A bunch of companies are already trying that. So if you want to enter in that specific market, try to follow the uWSGI project. Okay, I finished pretty early.
Are there any questions? Yeah.
Speak slow. I am Italian. I only play mandolino.
Okay, this microphone actually works. I have not understood why the rule for not reloading services exists.
I don't hear you.
I have not understood why the rule for not reloading components exists, especially seeing nginx does a really good job with that.
Comparing nginx config test with Apache, nginx wins 10-0. But I've found a couple of times nginx failing, not because of it, but because my config generator was broken. So it's a risky component. That's why I do not like reloading the system components. If you are good at writing a config generator, you are safe. Throw away the first rule.
Can I have a second question? We use HA proxy a lot for load balancing. I like the live status, getting very detailed information about queue length, throughput, etc. Do you have something similar?
Honestly, I will try to embed the subscription system to HA proxy and use HA proxy because it's really, really good at its job.
Okay, cool. I wanted to hear that.
Does that management process that monitors these slave process also detect if a slave process is hanging and not answering anymore any requests?
Yeah.
Then it kills it and restarts another one?
Yeah, you have to tell in your Vassal how much time a Vassal can be stuck at maximum. I don't know, 30 seconds. As soon as it's stuck for more than 30 seconds, the Vassal will die and will be restarted.
I don't mean only at startup time, but if it was running for a while and suddenly stops working, will it get killed and then somehow restarted?
Yeah, but it's something you need to configure. It's nothing automatic. You have to choose the policy on how to restart.
Okay, and the second short question is, can you configure a maximum request limit that one slave is getting?
Yeah. There is the max request option, and you can put how much request a specific Vassal on a specific node can receive. You pass that information to the Fastrouter directly if you want.
Why should I use nginx instead of Apache?
That's a good question. Apache lost a lot of its strength in the last few years because its model based on processes and thread was too expensive for the new massive amount of concurrent connection you need to manage in the current internet. Things will gonna change with the next Apache 2.4, obviously in the future, because they have changed their internal architecture and maybe they can compete with nginx.
You mentioned that uWSGI is a bad name because it's not just WSGI.
Yeah.
And I saw at first you were pointing each vassal or customer towards a particular Python WSGI file. But are you saying that there's a ways of letting people use web applications that don't use the WSGI interface and instead just listen to arbitrary socket connections?
Yes, you have a specific plugin for that should be developed. Currently, we have a plugin for each language specification, the plugin for PSGI, the plugin for rec. But yes, I have a customer that has released it in the public, a plugin for writing web apps in C. He has written its API. It's simple plugin for uWSGI. You load it and you will start that foolish.
I'm thinking of like non-Python, Python non-WSGI web server type.
Oh yeah, uWSGI, the WSGI plugin of uWSGI already supports other standards like Web3, WSGI Lite, another Pump, pretty unknown.
Thank you.
Yeah.
A question from this side. No.
This is the Italian side.
Ah, okay. Come on. This is only this side.
I assume that usually you are using CPython. Does it also work with PyPy and other implementations?
Currently, uWSGI is the only C application that can embed PyPy, because I've managed to send a bunch of patches to Armin Rigo. I don't know if he's here. No, it's leaving. Using the current development release of PyPy, you can take it from Bitbucket. You can build it as a shared library and build the PyPy plugin of uWSGI, and you will start using it. It's not complete. It doesn't support multi-threading modes. You can only spawn thread in your app, but your app cannot be multi-threaded. But I think it's the only limit currently.
As a follow-up question, if you support PyPy, there is this issue of this long warm-up time. If one slave is kind of warmed up, can you somehow maybe fork it so you get another warmed-up one?
uWSGI use fork in a pretty non-obvious way, as it fork after the app has been fully loaded. But yes, PyPy has a problem with the warm-up time. You see at naked eye. And you start seeing its improvement only after dozens of requests, even more. This could be a problem on web apps, but I know they are working on it.
Oh, okay. Seems, yeah, it seems we are done. Okay. Thank you very much, Roberto.